Hello everyone, my name is Charlie Kündü. I'm a student of the Electrical Engineering from the Kurova University Electrical Engineering Department. I'm doing my master right now. Today I will be doing task 3, which will be implementing naive algorithm to my dataset is the iris datasets and others. First, before I started, I want to give a little information about the naive Bayes algorithm, how it's worked. It's actually a three steps algorithm that first we convert the data set into a frequency table, and step two is the create a likelihood table by finding the probabilities like overcast probability you can see in here like 0.2, or and the probability is playing about 0.64 you can see right here. And now the step 3 is finally the use the now naive Bayesian equation to calculate the posterior probability for each class. The class with the highest posterior probability is outcome of the prediction. So why we are using the naive Bayes algorithm? What is the pros of it? It is easy and fast to predict the class of the test datasets. It also performs well in multi-class predictions when assumption of the independence of the host and naive Bayes classifier performs better compared to other models like logistic regression, and you need less training data. It performs well in case of categorical input variables compared to numerical variables. For numerical variables, normal distribution is assumed by bell curve, which is a strong assumption in this type of the machine learning algorithms. So it has some cons also, but it's not too many problem. It's actually the pre-processing problem that we have. If categorical variable has a category which is not observed in the training data set, then the model is assigned to zero probability and will be unable to make a prediction. You need to check your data processing very good if you don't deal with the problems. So I had used the iris datasets. First, you can see the sepal length, sepal width, and I will be plotting the values. You can see the species, and you can see the distribution of the sepal length and width, and also the petal length and width distribution. Also had imported the histogram of the values. If you want to consider it, you can check the libraries from the codes. I use the CNS and the Matplotlib. For the Bayesian, also I had used scikit learn Gaussian NB models. It will be easy for using such libraries. This is my code. I had used the training and tested the difference from the codes, and I had used the scikit-learn metrics for better accuracy results. In here, let's check our code. I started. Now you can see the says naive Bayes classifying matrix confusion matrix is right here. Accuracy naive Bayes is 100%, and linear regression to the classifying matrix is the mean absolute error, mean squared error, and mean root square error. So naive Bayes is in here is 100% giving, and linear regression with the iris datasets. In here I wrote in the code. I forgot to explain it in the further. I must tell it. Iris df and target df, you can see the converter of I want to use the species will become with a string, so I converted to the numerical variables. And linear regression code, I wrote it in right here. It split the data with the train and test side. I didn't use the validation side. And linear regression fit the X train, Y train, linear predicts, and used also scikit-learn matrix import mean squared errors. You can see the accuracy. The accuracy is very low with the linear regression, but it's very high in the type of the Bayesian algorithm. This code is also taken from the Kaggle competition, which has come the first. So you might want to check this. in this type of the models, we will be better to use the Gaussian algorithm for better results. I hope you guys understand the task. I wish you guys very good days. See you at another task.